Estimating quotients using multiples. Practice session. In this session, you will practice using multiples to estimate quotients. Example 1, 67 divided by 5. 67 divided by 5. In example 1, we're going to do the same thing that we always do. We look to see if our first number is bigger than the number after the division sign. If our first number is bigger than the number after our division sign. That is always going to be our first step. Is the first number bigger than the number after the division sign? So, is 5 bigger than 6? Would you rather have 5 bags of Takis or 6 bags of Takis? I don't know about you, but I'd rather have 6 bags of Takis. So our first number is bigger than the number after the division sign. Since the number after the division sign is bigger, we need to circle just the first number. We circle just the first number. I want you to notice something here. In the number 67, we still have that extra number that's outside of our circled number, but before our division sign. Before our division sign. Put a star around our division sign. You can see that the 7 is before it. This is going to be important here in a second. Because we need to ask ourselves, are there any numbers outside the circled numbers? The answer is yes. We just have to do one simple step to make sure we get the right answer. Since we do have a number, number 7, outside of our circled number, there's one additional step we need to do. It's super easy. The trick is just remembering to look for it and to remember the extra step. Alright, last example, 23 divided by 3. We want to look to see if our first number is bigger than the number after the division sign. 2 is not bigger than 3, so I need to circle our first 2 numbers. I need to circle our first 2 numbers. Remember that first step is the first number bigger than the number after the division sign? We then look to our numbers that we circled and ask ourselves, are there any numbers outside our circled numbers? Are there any numbers outside our circled numbers? So I look here and say, there are no numbers outside of our circled numbers. This will make our life lots easier. We don't have to do any extra steps. We count by 3s until we get to the number that is bigger than our circled number. Count by 3s until we get to the number that is bigger than our circled number. Keep going. 6, 3, 6, 9, 12, 15. Still not bigger. 18. 21. Go ahead and say it. I know you want to. And 24. Stop at 24 because it's bigger than our circled number. And then count how many times I counted by 3s. I have to say 2 actually. My apologies. 1, 2, 3, 4 times, 5 times, 6 times, 7 times, and 8 times. We counted our 3s 8 times to get to a number that is bigger than our circled number. We then find the number that is smaller than and bigger than our first circled number. 23. The numbers 21, go ahead and say it one more time if you want to, and 24 are bigger than 23. The rest of the stuff helped us get to the answer, but we don't really need it or care about it anymore. It's not going to help us anymore, so I'm going to ignore it. I then have the numbers 21, 24, 7, and 8. Now the numbers 21 and 24 are important because they show us the numbers that are smaller than and bigger than, but still closest to 23. The numbers we really care about, though, are the number of times we had to count our 3's to get to those two numbers. So we care about those numbers that are beneath it. I care about 7 and 8 more than I care about 21 and 24. Because 7 to 8, those numbers that are underneath, those count by numbers, are our answer. Now last thing, double check, are there any numbers outside of our circled numbers? And good for us, lucky for us, there are not. So we don't need to do anything else. Congratulations, put your name on it, put it in the math bin, and I'm very proud of you.